Hi, this is Adolph Oliver, and this is a video about finding the areas of odd-shaped things. Well, let's give you an idea of what we're talking about here. Odd areas can sometimes be found by using regular area formulas. We mean, a rectangle area equals length times width, triangle equals 1/2 base times height, those types of things. Now what you do is you start with a formula that would give the entire original area and then subtract the missing parts. Let's give you an example here. Let's say we had an original rectangle here. Okay, here's the rectangle. Okay, and we know about a rectangle that the area equals length times width. Well, here's the width, the shorter side, the length is the longer. Now, let's say that we have a triangle inside this. And what we did was we cut out this triangular shape. Well, the thing we know about a triangle, okay, is that the formula area equals 1/2 base times height. So this would be the base of the triangle, and the height would be the line coming straight down. That's the height. Well, if we want to find in all the other area that's here, so remember what we're doing is we took the original rectangle and we cut a hole in it, triangular shaped here. So what we want to do is find the area of the whole thing. Well, here's what we can do. What was the area of the original entire figure? It's a rectangle, so area equals length times width. Well, what we did is we cut out this triangular shape. Well, there's the base of the triangle and the height. So what we do is simply subtract 1/2 times the base times the height. Well, this would be the algebraic relation to find the area of everything else that wasn't cut out here. And if someone told us what the length and width and base and height was, we could actually find the number. But if we don't know all of that, we at least have an equation here which can tell us how to solve for the area of it if we knew that. Well, let's take a look at some examples here of what we can work with. Here we go. Here's one to begin with, and notice that what we have is a circle, but there's a triangle, okay, that's been cut out of the middle of it. We want to find the shaded area as a polynomial. So we don't have the actual numbers, but what we're going to do is figure out what the value would be just with the letters. Okay, well, first off, this main guy is a circle. Okay, and circle, the area equals pi r squared. Okay, well, notice they tell us to use b for the radius, so we'll come back in a moment and get that. Now, what was cut out of this is the triangle here. Okay, and of course, triangle, you have to remember, area equals 1/2 base times height. So, what's the area going to be just of the shaded parts here? Well, if the whole circle was there, and then of course remember they tell us to use b for the radius, so it would be pi b squared. That would be the whole circle. But we cut out the triangle in it, and so what we have to do is subtract that part out. Well, here's the formula for the triangle right here, but they tell us to use x for the height and y for the base. So we're going to be subtracting out 1/2, but the base we write as y, and the height we write as x. Okay, there's our polynomial right here. that gives us the area of this. It's a pretty powerful technique. Finding this area by any other method would be very difficult, but it's very easy by taking the whole original part and subtracting the part that's been removed. Okay, well, let's look at another example. Once you see how to do this, it's not a difficult process and something you can look to. Now, here we go. Find the shaded area as a polynomial. Okay, well, if you take a look at this, originally there was a rectangle here. I'll kind of dot in the other edges here. Here they are. So there's an original rectangle. Okay, let's put down what that is. And of course, remember the area of a rectangle, the generic formula, A equals length times width. Now, there are two squares here, a smaller one and a larger one. The area for a square, since the sides are all the same, is A equals S squared. Well, again, we do like we did on the other example. First, let's find the area of the entire rectangle. So area equals, now notice they tell us to use X for length and Y for width. So since we multiply those together, okay, area equals length times width, the area of the original rectangle, if we hadn't cut any of the square pieces out, would just be A equals X times Y. But now we cut out two squares. The larger one here, and it says the side is A. So remember the formula is S squared. Well, the side, we're going to use A for S, so minus A squared. Now that removes the larger triangle, but we also have to remove the smaller one that's in this corner. So we also subtract that one. It's the same formula, S squared, and we use B for the variable for the smaller square, and of course don't forget to square it. So once again, here's our polynomial, which gives us what the area would be of this shape. Okay, well, sometimes we can be given some of the numbers to work with here. Let's take a look at this example and see what we have. Okay, notice over here, let's see, we've got what was originally a trapezoid here. I'll dash across the top of it. And then we removed a half circle from it, cut that out. Well, trapezoid, okay. Trapezoid, the area equals, okay, the average of the top and bottom sides. Okay, this is usually called A and the one in the bottom B, but folks use different letters. But A plus B divided by 2, and then the height coming straight down, the H. So this would be A, this would be B, and I'll just put the H out in front here. Here it is. Now, the half circle that we have here, a full circle, the radius, or the area I should say, A equals pi r squared. But we have a half circle, okay, only half of it's here, so the area of that's going to equal 1/2 pi r squared. We just take the regular area and just take half of it. Okay, well, here we go. We want to find out what this is. So again, the area of the whole original object here, the trapezoid, and they tell us to use 4 for the top, 8 for the base, so A and B are 4 and 8, and then the height is 6. So it's going to be 6 times 4 plus 8 divided by 2. Okay, that's the full area of the trapezoid if we had not cut the half circle out. But now, of course, we did cut a half circle out. So minus 1/2. Now pi, they tell us to use 3.14. Here it is. And then, of course, we have to have the radius squared. So 2 squared. Okay, I've used these formulas that I had, but I plugged in the values they told us to use. Okay, well, let's start evaluating all of this. Let's see, one thing I can do here is I can reduce the 6 and the 2. 2 goes once here, and the 6, it goes 3 times. So this is going to be 3 times, and of course I got to add together the guys inside before I can multiply. 4 plus 8 is 12. Now we'll come back and finish that up in a moment. Over here, we've got 2 squared, which of course equals 4. So I know what that is. And remember, multiplication commutes, so I can take this 4. Remember, these guys, if I want to make fractions out of them, I can put 1 underneath. So these guys are on top. So I can put this 4 out in front of the 3.14. And don't forget, I still got a 2 downstairs that I'm dividing by. Well, let's keep working on this. Here we go. 3 times 12 is 36. Now, the 2 goes once here, and into the 4, it goes twice. So I'm going to be subtracting 2 times 3.14. Well, if you take 2 times 3.14, you're going to get minus what? 6.28. All I did was just double these guys. That's multiplying by 2. Well, we're getting real close here. The actual area then to finish up on this, 36 minus 6, so it's going to be 29 point. Now if I subtract the 0.28 from this, remember what we're really doing. I can put it over here to show you. 36.00 divided or subtracting 6.28. We had to do some borrowing here. 5 or 10 here, borrow from that. So I have 10 minus 8 is 2, 9 minus 2 is 7, and then of course this is where I got the 29, 35 minus 6. So 29.72. Now they didn't tell us whether these were inches or feet or anything else, so there's nothing else we can add down here. But remember, if you are given units, you do have to indicate what they would be. Okay, let's look at one more example here. Again, of these odd-shaped areas. Okay. Here's one where what we have is an original rectangle. Let me dot in what the edges would be. Here's the left edge. Here's the right edge. So this is an original rectangle that we've cut 2 triangles out of. One on the left, one on the right. So the area again of the original triangle, okay, or I should say the original rectangle, there we go. The area of the original rectangle, if we had not cut the triangles out, area would equal length times width. But each of the triangles now, remember there are 2 of them, the area of a triangle, okay, again, A equals 1/2 base times height. Well, okay, let's put the formulation together on this. The original area, if we had not cut out the triangles, would equal length times width, and they tell us to use 5 for the length and 2 for the width. So it's going to be 5 times 2. Okay, that's just substituting for length and width here. And that would be the area of the original rectangle. Now we're going to subtract from that 2. So here's the 2 right here. You know, one triangle here, one triangle there. That's a total of 2 of them we cut out. And then times their formula, 1/2 base times the height. And they tell us to use base equals 2 and height equals 2. Okay, so there I've substituted in the numbers right to begin with. Well, let's start cleaning this up. 5 times 2 is 10 here. Now notice I can make a fraction out of this 2 in front by putting a 1 underneath it. And so I can reduce this 2 against this 2. So they all become 1s. So the only thing I'm subtracting here now is 2 times 2, which is 4. So I reduce the 2's against each other. Okay, they all reduced to 1. This became 1. And I've got 2 times 2, so that's a total of -4. So the area of this then equals a total of 6. Now once again, we're not given any units here, but if we were, you should put them down. But since we're not, you can just leave it as 6.